All right, now we are in, I think this is part 4. We are looking at factoring a quadratic in standard form. Standard form we've talked about, but standard form is just when it's in, the exponents are in decreasing order. So here we have a second x to the second power, x to the first power, and then your constant is really x to the 0 power. So before you start factoring with any quadratic, you want to make sure it's in standard form. Section, we're going to look at factoring a quadratic in standard form only when the leading coefficient is 1. So remember, we talked back here about how these are the coefficients. This term, the highest exponent term, is called the leading term, and then the coefficient in front of the leading term is the leading coefficient. So we're looking at examples where the leading coefficient is 1. So we're going to look at it using what's called the AC method. So I want to first start out by identifying A, B, and C. A is 1, B is 7, C is 12. And these are the same A, B, and C that we use when we use the quadratic formula. If you remember the quadratic formula, let's see, right here. Quadratic formula starts when it's in standard form, and it's the same A, B, and C you use in the quadratic formula. So we want to find two numbers that multiply to give us A times C, which in this case is 12, that add together to give us B, which in this case is 7. So we need them to multiply to give us 12 and add to give us 7. So all the ways we can multiply and get 12 are 1 and 12 and negative 1 and negative 12, 2 and 6 and negative 2 and negative 6, 3 and 4 are negative 3 and negative 4. And obviously the only two of those that add to give us 7 are 3 and 4. So in this case, because that leading coefficient is 1, it's not going to work if the leading coefficient is anything other than 1. But because that leading coefficient is 1, we can go straight to the factors from these two numbers here. I call this number my magic pair. And we can factor it to be x plus 3 times x plus 4. And that's how you factor when the leading coefficient is 1. So that's your factored form. Let's look at another example. I'm going to go up underneath here. We're going to do this one first. So this one obviously does not have a leading coefficient of 1. This has a leading coefficient of 2, but you should always try to factor a greatest common factor out first. So if you look at all three of these terms, you'll realize that they're all divisible by 2. So I can first factor out a 2, and then that leaves me with x squared plus 3x minus 4. So now I have a quadratic where the leading coefficient is 1. Be careful though, because you can't lose that 2 in the factoring process. You want to stick with that 2. So I'm just going to go ahead and set up my factoring skeleton over here so that I can put my final factored solution there. And then I'm just going to factor the same way I did example 1 above. I'm looking for two numbers that multiply to give me A times C, which is negative 4, that add together to give me positive 3. And I need one to be positive and one to be negative. I need them to multiply to give me 4, negative 4, and add to give me positive 3. So that's going to be positive 4 and negative 1. And because this leading coefficient is 1, I can go straight to my factored form. X plus 4, x minus 1. And that's my factored form for example 3. I'm going to encourage you to do example 2 and example 4 on your own. So pause the video and try these two on your own using 1 and 3 as an example. All right, hopefully you had a chance to work through these. I'm going to do these together, and then we'll go ahead and do the rest of the problems together as well. So we're looking for two numbers in this case. There's no common factor, obviously, because there's a leading coefficient of 1. I want two numbers that multiply to give me negative 12, that add to give me negative 4. So I need one to be positive and one to be negative because I need my product to be a negative number. So I believe it's going to be -6 and +2. You may still need to write out all the factors of 12. That may help you just to look at them. But I need their difference to be a 4 so that I can have that when I add together, I get a 4. So then these are my two magic pair numbers, and because that leading coefficient is a 1, I can go straight to my factors. And this factor is to be x minus 6 times x plus 2. And then number 4, looking at these three terms, they're all divisible by 3. So I'm going to factor out that 3 first, not lose it. Let's do. And then that gives me x squared minus 5x minus 24. Now I got a quadratic trinomial with a leading coefficient of 1. So I'm looking for two numbers that multiply to give me -24, that add to give me -5. Again, I don't want to lose my 3. So I'm going to go ahead and set up my factors over here so I don't forget that 3. And then two numbers that multiply to give me -24 that add to give me -5. I know one has to be positive and one has to be negative. So I'm going to think about 24. I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And so the two that are going to combine to give me a -5 are going to be 8 and 3. So this is going to be a -8 and a +3. Because that leading coefficient is 1, I can go straight to my factors. So the factored form is 3 times x minus 8 times x plus 3. And I would encourage you to pause the video here and try these on your own. And then there's a little bit of a mixed practice down here. And you won't quite be ready for these because these will need to do on day 2, but you should be able to do A through I, number 17. So just take a few minutes and see if you can do these on your own, and then resume the video and you can check your answers. All right, so for this one, I'm looking for two numbers that multiply to give me 6, that add to give me 5. That's going to be 3 and 2. So this factors to be x plus 3 times x plus 2. Next one, two numbers that multiply to give me -6, that add to give me -5. It's going to be -6 and +1. Go straight to the factors because my value of A is 1. So x minus 6, x plus 1. And that's my factored form. It's a good idea if you're struggling to go ahead and list out your A, B, and C. That's a good habit to get into anyway. A is 1, B is 9, C is 20. Two numbers that multiply to give me 20, that add to give me 9. That's going to be 5 and 4. And because that leading coefficient is 1, I can go straight to my factors, x plus 5 times x plus 4. Number 14, A is 1, B is -9, C is -36. So I'm looking for two numbers that multiply to give me -36, that add to give me -9. You got this as you came in the door, so if you're not sure how to use one of these, this is just a multiplication table. So all the factors of 36, I can highlight. 36 is 9 times 4. 36 is also 6 times 6. 36 is also 3 times 12. Here's 9 times 4 again. And 3 times 12 again. Those are all the ways you can get 36 by multiplying. So then I'm going to go back up here, and 12 and 3 are going to be my two factors. I need them to multiply to give me negative 36 and add to give me negative 9. So I know the 12's got to be negative. So then this factor is to be x minus 12 times x plus 3. And that's my factored form. Number 15, my leading coefficient is not 1, so I'm going to check to see if there's a greatest common factor. And there is. I'm going to factor out a 2. So then that factors out to give me x squared plus x minus 42. And I don't want to forget my 2, so I'm going to go ahead and write out my factored form over here with the 2 because that's an important part of the factored form. And then my a is 1, b is 1, c is negative 42. So I'm looking for two numbers that multiply to give me negative 42 that add to give me positive 1. And that's going to be positive 7 and negative 6. So I'm going to go straight to my factored form. X plus 7, x minus 6. Number 16, again, my leading coefficient's not 1, but all three terms have a factor of 4. They also all have an x. So I'm going to factor out a 4x. That's going to leave me with x squared plus 3x minus 10. So now I have a is 1, b is 3, c is negative 10. So I need two numbers that multiply to give me negative 10, that add to give me positive 3. That's going to be positive 5 and negative 2. So my factored form is 4x times x plus 5 times x minus 2. And then going on with these three, I'm going to go through these pretty quickly because the video is getting a little long. But I need 6, 5, that's going to be 2 and 3. We just did this one. And this is two numbers that multiply to give me 9 that add to give me 6. It's going to be 3 and 3. This is difference of squares, so it's the product of the sum and the difference of the square roots of each term. This is sum of squares, does not factor. Only difference of squares factors. On Wednesday, we're going to look at sum and difference of cubes, both of which factor, but sum of squares does not factor. Here we've got negative 8 and positive 2, so that's going to be positive 4 and negative 2. So that factors to be x plus 4 times x minus 2. Here we have two numbers that multiply give me 25 that add to give me 10 are 5 and 5. So that's going to factor to be x plus 5 times x plus 5. That's what's called a perfect trinomial square, or x plus 5 squared. Letter G, two numbers that multiply to give me negative 12 that add to give me negative 4. It's going to be negative 6 and positive 2. So this factors to be x minus 6, x plus 2. Two numbers that multiply to give me 4 that add to give me 4. It's going to be 2 and 2. So that is x plus 2 times x plus 2, which is also x plus 2 squared. And then finally, letter H, two numbers that multiply to give me 16 that add to give me negative 8. That's negative 4 and negative 4. So that factors to be x minus 4 times x minus 4, which is x minus 4 squared. And that is number 17, A through I. And then we'll pick up on these after we do day 2 lesson. But that is, in a nutshell, that is factoring quadratic trinomials when the leading coefficient is 1.